Project Antrea. This was a project that was open sourced by VMware last year at KubeCon US, and is a project that is actually taking on a very rapid and I would say aggressive development approach. The evolution is really quite impressive with the number of features that are coming out of this project. And really my goal tonight is to just introduce you to the project, give you an idea of what we're trying to accomplish, and really ask for your help. This is a community project, and we see a lot of things that can be done with networking inside of Kubernetes, and we want your help. We want to make sure that this is something that the community all comes together on, so that we can build and move more towards a version 2 type reference implementation of the networking model within Kubernetes. And so, without further ado, I'll get started. Just by way of, as you have already probably figured out, I do work at VMware. I'm focused on container networking in the network and security business unit there. And you can always reach out to me at McCodeman on Twitter or GitHub. And if you want further information about what we talk about tonight, you can always hit the project's website at antrea.io. So let's dive in. So what is Project Antrea? Very simple. It's an open source CNI network plugin providing pod connectivity and network policy enforcement with open vSwitch in Kubernetes. A lot of icons at the bottom right, so we all know Kubernetes, and we're probably all fairly familiar with CNI. Open vSwitch is a very well-known and mature software-defined networking suite that can work across multiple operating systems, including Linux and Windows. And what it allows us to do is, take the best that has been developed at a software-defined networking layer and then orchestrate that with Kubernetes and basically be able to plumb our Kubernetes workloads with the networking connectivity and policy enforcement that they need. This is a really, really new project, okay? We started in July of last year, open sourced at KubeCon. And, with this, we've already got 595 GitHub stars, 88 forks, 20 contributors, 10,000 plus downloads. We are looking to increase that number, and we're really getting some great participation from the community, a lot of interesting work that we're going to talk about through the rest of this presentation. I also put our GitHub repository information there. I'll include a slide at the very end if you want to write that down. But we encourage you to pop over there. You can also hit it from antrea.io, which is a little easier to remember. So the first question, and it's probably the biggest question in the room, is why Project Antrea, right? Isn't there already a bunch of CNI work out there? What about Calico? What about OVN, We, Flannel, and Cilium? Yeah, there's a lot of CNI projects out there, but a lot of these projects that have come and gone have been based on Linux kernel networking primitives such as IP tables. There is some new work going on with extended Berkeley packet filter. But Open vSwitch actually brings a very interesting architecture and capability to the scene. And we felt that even with OVN out there, that there wasn't a very native approach, sort of Kubernetes native approach to networking that took advantage of the stability, the performance, flexibility, and the extensibility that Open vSwitch brings to the table. What we're really hoping to achieve from this project is, and we're already seeing some great results in our scale testing and performance testing, is we're going to get improved data plane performance. We're going to get Windows compatibility, and Windows compatibility that's not hacky, right? We'll be able to actually have an OVS native interface to both operating systems, right? And that's a game changer, because what it's going to do is allow our orchestration and control planes to evolve in a uniform manner. We're going to get deep diagnostic capabilities. We're going to get easy extensibility. And like I said, it runs anywhere, right? And it won't matter if we're running on an overlay or a non-overlay. Whether we need to do routing or forwarding or basically be chained with another CNI and just provide policy enforcement. There's a lot of different ways that Kubernetes is deployed into the wild, especially in managed solutions. And we're looking at Project Antrea as just a simple drop-in CNI to whatever deployment style that you want to face. The thing is that we're really looking for how Antrea will help in the arena of scaling and multi-cluster, right? These are the hard problems I talked about in the advertisement for this meetup. These are the things that, all the easy problems of networking have kind of been solved. Where it's really going to start getting challenging now is as we move into both hybrid cloud and, multi-cluster approaches. And we really think that the OVS data plane is well positioned to make those types of connectivity a game changer. So let's give a little bit of review. When we're talking about Kubernetes networking, there's a couple different things that we can talk about. One obvious one is just moving packets from one pod to another pod. And my next slide will go a little bit more into the CNI. But above that, and then moving packets, we have the capability to establish network policy, right? These are essentially a distributed firewall rule that's enforced at the edge of every workload. So one of the things that we want to achieve in a cloud native application is we want to restrict how that application or who that application talks to and the inbound requests that application gets. We want to restrict that cloud native application only to its service graph and really want to give it the least number of connections as possible. And we can do that with network policy because it gives us a very powerful DSL that allows us to implement policy based on the metadata of the workloads that we're already running. And so I can, do things like have a mail server, for example, and I can have a policy for a mail server, and it basically says that in that policy for that mail server, first off, I would label that mail server as a mail server. I may say something like key mail value as server, right? And then I could have a policy that says only allow inbound connections from things that are mail clients. And conversely, on a mail client, I could have those keyed off as mail : client, and I can say, we're only going to allow you to externally connect to things labeled mail.server if I'm connecting on a mail port. That's very powerful because when we talk about cloud native applications, especially with Kubernetes, scaling is what we're really trying to be able to achieve here, auto scaling of our pods. And as those pods scale out, those policies are going to follow those pods, no matter which compute node that they scale to. The two terms that we have here, we kind of talked a little bit about network policy, but we also have in Kubernetes the concept of a service. And what this allows us to do is to apply a virtual IP and a name to one or more group of identical applications or microservices, right, that are fulfilling some type of a service. And part of the communications process, so for example, if I'm in a pod or within Kubernetes and I make an outbound call to a service, say I've got this mail service that we were talking about earlier, the first thing that I have to do is translate that virtual IP into the actual concrete IP that it's going to be delivered to. And so there's a form of load balancing that's occurring here. And we typically call it service load balancing. And this is just a fundamental part of Kubernetes. The problem is that the original implementation within Kubernetes was all done in IP tables. One of the goals that we're looking to achieve with Project Antrea is actually to move that translation out of IP tables, which is not designed really for that type of load balancing and is quite frankly just not performant at all. And even out of IPVS, when we talk about inbound ingress as well, but to move those out of those underlying kernel primitives, move it into OVS, directly into our OVS data plane, we're going to see some really incredible performance increases once we're able to do that. And also, it will unify the experience, on Windows and on Linux. And so, these are some of the things to really pay attention to what's happening right now in the project. A little bit more review, right? We talked about the container network interface. This is actually the low-level API and primitive that we actually get a handle to the actual workloads, the containers or the network namespace, right? In Kubernetes, a pod can be multiple containers, but it's isolated into its own network namespace, which means that it gets its own ETH0, it gets its own view of the networking fabric and its connection to that networking fabric. And what the CNI does is projects like Antrea implement an interface that allows the container runtime orchestrator to request that a workload gets plumbed for networking. And so that request is made by the orchestrator using the CNI API, and it would say something like, "Hey, I've got a new pod, and it's going to need an IP address. It's going to need a interface, virtual interface plumbed to it, and it's then going to need to be connected, to the rest of the Kubernetes cluster, so that we're going to have to either do routing or forwarding of packets, and it's got to know basically pods when they address another pod within the cluster. We're going to rely on whatever plumbing and routing that you set up to move that packet from one pod to another pod. And so Project Antrea has that third-party CNI plugin. CNI does not, however, define network policy, and that's an additional feature set that Antrea brings to the table. The Kubernetes network policy is one of the APIs within Kubernetes that just doesn't come with a default implementation. But by choosing a project like Project Antrea, when you do declare network policy on workloads, you will get that implementation or that policy enforced by the Project Antrea implementation. So let's take a pause here. First off, if you have questions that are inbounding, Jason, please let me know. I don't have the Zoom. Oops, sorry. I don't have the Zoom interface directly in front of me. So please chime in if you have any questions that are hitting as we're going along here. So from an architecture perspective,
so far, but do feel free to also add them to the chat. I'll watch the chat window for questions as well if you don't want to actually ask them over microphone directly.
That's awesome. Open vSwitch is a kernel. Well, it can actually be run either in kernel mode, or it can be ran in user space mode in Linux, and it also can run as a networking driver in Windows as well. And what Project Antrea does is it actually implements Kubernetes native patterns to drive the configuration of OVS. And OVS is what is going to actually provide us the network connectivity between our pods. And it can do it in a variety of ways. One thing it can do is it can use an overlay. And so in an overlay network, we assume that hosts can reach each other, right? And for anything to work from a Kubernetes perspective, right, the hosts all have to be able to talk to each other. That's a prerequisite. So there's got to be some type of underlying fabric configuration that these hosts are all connected to, and they can forward packets. But just because the hosts can talk to each other doesn't necessarily mean the pods know about where other pods are located. And so that's where a CNI comes into play, because it's going to keep track and account for where pods are being spun up and how to actually route packets from one pod to another. So one way that it can do this is with what's called an overlay. In an overlay network, we literally create an envelope in IP using something like VXLAN. We can use Geneve, STT. Open vSwitch has a support for a lot of different encapsulation protocols, and we can then stuff inside of this encapsulation packet the pod's communication, right? The packets that are coming from the pod, and then the node then will basically ship it to the right node on our behalf and unpack it there so that it can get delivered to the destination pod. As with any type of an encapsulation that's occurring, there's overhead involved, and in in some clouds that can't be avoided because of either how the cloud is set up or the access that you have to the underlying fabric to actually be able to influence things such as routing. And so it's always great to be able to have an overlay because I don't have to necessarily have a relationship with the network team, right, to get my Kubernetes cluster up and running and to establish communication between the pods. However, if I want an even more performant configuration, we want to try to ditch the encapsulation and go with a native way to transport IP packets. And so Project Antrea also supports a no encapsulation mode where it can either completely defer all movement of packets to either another CNI or the fabric itself, or it can and just implement policy only in that regards, or it can provide forwarding and routing on its own as well. And in this case, and we don't have this feature yet, it's a feature that we have on our roadmap, but we will be, eventually able to exchange routing information with the underlying fabric as well, so that we can move packets along without having to rely on encapsulation. Some other things that I wanted to point out that's really powerful with Open vSwitch here is everything is processed and has as an open flow, and these flows are always persistent, and which means that we can actually upgrade the data plane and control plane without having interruptions, and that's really important in something like Kubernetes that's always evolving and changing. Just a little bit deeper dive into the architecture and kind of the components that make up Project Antrea. We have an Antrea controller, just like you would have any other type of Kubernetes controller, and it's following kind of an operator or a controller pattern that's monitoring CRDs for changes. The CRDs are specifying what we intend to happen. So from a network policy perspective, right, the spec of your network policy CRD would say what you want protected. Writing that spec doesn't protect anything. It's actually when something like the Antrea controller reads that CRD and decides how it should be enforced is when the enforcement actually takes place. One thing that we do differently than other CNIs is we actually compute all of our implementation rules centrally. And then we distribute only what's necessary in a differential basis to the agents that will actually be enforcing that rule. What that allows us to do is one, be able to require less compute on the worker nodes where those agents are running. But two, it also allows us to take advantage of things like caching and other things that will speed up the calculation of the rules, and basically by looking at when we calculate rules, we have to understand the metadata of the workloads and how those actually apply to our rules, and all of these things are always changing, right? These are state is always changing, right? So you're always getting either pods coming and going, labels that are changing, or the rules themselves that are changing, and having a very performant way to calculate those rules is important to make sure that you can converge very quickly when changes occur. One of the Antrea agent is what actually runs on every single node. Currently, we do rely on IP tables, as I mentioned, to do the VIP translation. So like when a service is used instead of a direct IP to a concrete pod, we are actually having to go out to IP tables, right, to actually make that translation for us. However, when we as you'll see in our timeline here in a minute, we'll get the OVS-based kube proxy in place. All of that will happen in the data path, and it'll be much faster than what we're seeing in current IP tables implementations. Finally, we definitely require that the Linux kernel be a current kernel, and most current kernels. The nice thing about most current kernels is they do already have the OVS module available. And in cases where, rare cases where you don't have the ability to put that module in place, you can also default to user space implementation. Another nice side effect of that is it actually allows Antrea to work inside of kind as well. And so we can use that user space implementation there for testing and training and debugging. So let's talk a little bit about scale and performance. We really think that, if you consider how young the project is and how quickly we've built the control plane and data plane, we're already getting some really impressive scale tests back. And this is just the scratching the surface. We have several other research projects internally within the project that are going on optimizing the way that we process rules and the way that we communicate with the agents, et cetera, to continually to hone down on this performance. We can simulate 2,000 nodes, 100,000 pods, and we can calculate 10,000 network policies and send that to those 2,000 nodes in 4 minutes. And if you think about how many policies that is and how many nodes that we're talking about, it's really quite an impressive number. And once we've made that, and this would be a cluster that's coming up from scratch, right? Where we're really going to shine in terms of performance is dealing with a high rate of a request that's like an HTTP GET request, for example, right? Where it's the same type of request coming in over and over. The nice thing with Antrea is that we can actually be 2 to 3 times faster than other CNIs using IP tables with that type of request, because of the way that OVS uses tables and caches that actually down in the kernel. Additionally, we can realize 10,000 flows in 300 milliseconds, which means that we can rapidly add flows. And so, this is going to be really important as, if we think even into the future, maybe with, functions as a service, for example, right? And functions coming and going and needing to actually keep our security policies and changing them and syncing them at a rate that keeps up with things like function as a service. These are some really interesting things to think about of where network policy is going to go. So we will attempt to do a live Rancher demo. I'm going to go ahead and start this spinning up. So let's see if I can pop over to do that. Sorry about that. Here we go. Okay, so I am going to run. Can you make that text a bit
larger?
Yeah, I will blow that up. Sorry about that. How's that, Jason? Everybody see that okay?
I mean, my eyes aren't great. I can see it.
Excellent. So let me show you first off what I've done. I've gone in and I've downloaded just the quick start for Rancher, right? I just wanted to show you how easy it is to drop in Project Antrea as a CNI into Rancher. So there's a couple things that I needed as a prerequisite to make this happen. First off, I needed the Antrea YAML, which is, if we take a look here at the Antrea YAML, this is literally just the deployment YAML, right? That deploys the controllers and sets up the service accounts and the roles and everything that Antrea is going to need to operate as a CNI, right? So you can get that off of the GitHub repo for Antrea under releases and download that Antrea YAML. The second thing that I needed was the Rancher quick start. Now, this would work with just about any provider. I have a pre-built one with AWS, but it would work with Linode. It would work with Azure. However we want to set this up. If it supports an overlay, our default configuration for Antrea goes into overlay mode, and so you can just drop it in as a replacement. So let's take a look quickly at the values that we set. The first thing is, if you look at the Terraform, and let me pop over here to, let's see here. Pull this over here and make this a little bigger. Whoa, that might be too big. Let's see. So in the Rancher Terraform under Common, I went in and I actually just changed this one configuration in the RKE config. So basically what this quick start does is it spins up your Rancher management cluster, right? And then it spins up, and please correct me, Jason, if I get the wrong terms here. But then it spins up the actual workload cluster that you're going to spin your workloads up in. And what I basically told it is I don't want a network here. So I'm just going to select none. Now I plan to work very closely with Jason and the other Rancher folks after this meetup, and hopefully we'll have soon a way to just pop in Antrea here as well. But for now, you just say none, and we'll go ahead and start that process running. So we'll say Terraform apply, and this is literally going to reach out and create some infrastructure.
So
this is going to take just a second. So while that goes, go ahead.
You ever say any questions while the Terraform's running? Yeah, nothing so far.
Okay. So while that is going, let me pop back over here, and I will also mention, a shameless plug here, that we are excited that we literally just launched our Antrea website at antrea.io. So if you want to find out more about what we're doing in Antrea, there's a couple of ways that you can do that. One is obviously hit our website, right? You're going to find, so, that's where we're going to be capturing blogs, where we're going to have community information, and we're basically have all of our documentation. So you can actually get into the details of, what we're doing with OVS, how the actual architecture works. We've also got some great quick starts for different clouds. The Linode folks need to give me a holler. I want to get one for you guys as well, and get LKE in here. So we have a lot of ways to get involved in the project. If you want, right now, being that it's such a young project, one of the easiest ways that you can jump in is starting with documentation. We're always looking to improve our documentation and make it easy to get started, using Antrea. And don't ever underestimate the value of going in and correcting documentation or adding additional context to the documentation that's there. I'm always amazed every time I look in the Kubernetes community to see, how many newcomers there are every year. And, just because we think there's a lot of people that have jumped into Kubernetes, there's really a lot of opportunity, still remaining for us. So definitely take that opportunity to jump in. Also, some of the things that we're thinking about, and I'm going to pop back over to my presentation while that runs. I told you it was a live demo, so definitely meant that.
So while it's running, William Christensen had a question. Has anyone tested Antrea with K3S?
We have not tested it, and I would actually, I chatted with the K3S team when I was at KubeCon, and I would love to get that started. OVS will run in Android. We have actually quite a bit of sorry, not Android. ARM is what I meant to say. Sorry about that. It will run on the ARM architecture, and we have quite a bit of interest from the community in making sure that we have ARM support for any type of IoT and edge computing use cases. And so, if that's something that the K3S folks are interested in exploring, hit me up after the meetup, and let's actually talk about how to plug your Rancher or whoever else into our contributor pipeline and actually get those things merged upstream. We'd love to do it.
Awesome. Thanks,
any other questions?
I'm not seeing anything else in the chat, so you're good to go.
So let me tell you kind of what we have available now, right? It's a new project, but it's already usable. And matter of fact, within VMware, we've actually already got several large internal clusters, upwards of hundreds of nodes that are using it as its CNI. So, we're trying to learn some lessons right now. Obviously we're going to provide some commercial support for that as well. in an upcoming release this summer. But before that, we need to get as many people's hands on this, and we really, again, want to get external contributors outside of VMware, because we want your ideas incorporated into this project, right? We know that there's a lot of great ideas out there, and we'd really like you to plug in with us. We already have, as I mentioned, overlay networking, right? So we support Geneve, SET, VXLAN. We've even got GRE. We do IPsec. We've got Kate's network policy. We can do, various types of observability with our monitoring CRDs. We can actually expose a lot of the OVS internals using the status in CRDs for our agents and controllers. We've got, Octant UI plugin for visualizing controller and agent health. We run on-premise and public clouds. The idea is that we want to be a common data plane as we start looking at these multi-cloud and multi-cluster use cases. And we, run a no encapsulation, which is really important for a lot of the managed Kubernetes distributions, right? So if I were to spin this up and say, EKS or AKS, for example, they have, native CNI implementations that take, advantage of their networking abstractions, at the IaaS layer. And so we just basically back out of the way and say, we'll just do policy only in those cases. That's not to say that you can't run in an overlay if I want to run on top of EC2 or other things like that within AWS, or if I want to run, on top of nodes in Linode, and I want to set up my own overlay, maybe because of the way that the restrictions I have on public routability of pods, those types of things. Those are all use cases that we're looking at, and as we further our development of the routing layer, you'll see a lot more of these types of things open up. One of the things that I haven't talked about yet that I think is going to be a key differentiator of this CNI, and it's really going to be around the diagnostics and troubleshooting tools. OVS has a really powerful way to expose things like packet tracing, flow logs, right? And output those in formats that existing network operators are already used to, and feed various analytics and intelligence engines, right, that are looking your IPSs and such, that are looking for intrusions. And so we're going to take advantage of that and actually provide lots of ways to export information out of this data plane so that it can be used for additional analysis. Right now, we're working on version 0.6 and 0.7. Matter of fact, I have several of our engineers in the call tonight. And so, if you've got specific questions about how something works or what you're looking for, I can definitely defer to some of them as well. But just as a short list, we're working on Prometheus integration so that we can provide metric support. As I mentioned, Windows support is right around the corner. We're working on the OVS native kube proxy, right, for performance. The trace flow tooling. So, this is a really cool feature that's going to basically say, hey, I want to inject a trace packet, right, from a source to a destination, and I want to understand actually how that transited my topology. From an infrastructure person, this is very, very valuable. To know exactly how it's going across your network without anything being hidden. Additionally, we're again continuing to improve our documentation on how we use in public clouds, and I also hope to provide this rancher documentation too, and different use cases there. The use case I'm doing is a simple quick start, but we could actually work with an EKS, an on-premise rancher management. There's a lot of different ways that can be done. In terms of our roadmap, we have I think, very aggressive and rapid innovation in our future. I've mentioned some of these things like IPFix and logging, packet capture and tracing. Think of the typical network tool set that we have today and the ways that it's centralized. And what we're really looking to do is to distribute those tools across our nodes and really bring a cloud native pattern and approach to traditional networking tool sets that are providing us, the intelligence on who's knocking on our network doors and how those networks are being used. We also are focusing really heavily on the lifecycle management of the cluster, right? We know that Kubernetes clusters get upgraded. We know that it's a very rapid innovation, and so we want to make sure that upgrades are seamless and flawless, and that workloads are not you're not losing connectivity as we go to the next step. And we've already provided patches in our current release today that does maintain persistent connections that does that. But we'll continue to enhance that capability. We also wanted to, as far as lifecycle, which I don't have listed, is provide migration paths as well for some CNIs are actually going out of support, right? They're just no longer being maintained. And so if you're on one of those CNIs, we want to make it easy for you to get into Antrea. Additionally, from a multi-cluster perspective, we're focusing really heavily on policy distribution, multi-cluster management. We know that in the enterprise, if you think about where clusters are going, in some enterprises, a cluster is very multi-tenant, and it's kind of a centralized aspect. But in other cases, like if you go into the cloud, right, clusters become ephemeral. And you might end up with mini clusters and clusters per application, those types of things. So being able to understand how that policy is distributed and managed across multiple clusters is becoming more and more important. And with Antrea, we're providing a lot of thought in the way that we build our APIs, so that if you want to integrate with some type of a higher level global policy engine, that you run in your enterprise, VMware, we have things like NSXT, for example, that can do this, and there'll be other options, I'm sure. With that northbound API, we'll actually be able to observe and distribute policy into Antrea. And we know that policy is going to come from different sources, right? You're going to have platform operators, you're going to have network operators, you're going to have the developers themselves. And so just understanding how to do conflict resolution on those policies is really important. Additionally, we want to focus a lot on network policy and improving, moving towards the network policy V2. We're already actively engaged with the network SIG, and I know that there's a lot of brainstorming going currently on network policy version 2. Some of the things that we're going to do with our policy that goes beyond just standard Kubernetes policy is enhancing our endpoint selection traffic matching engines, doing DNS egress filtering, looking at QoS and time-based policy, and also cluster scoped policies. In terms of things like service mesh, we definitely know that that's something that the CNI has to interact with, and we will definitely be doing a lot of service mesh integration work as well.
Hey, Cody, finally, we got a question real quick.
Yeah.
So somebody asked that currently does it support any packet capture?
So we don't have that built into the ant cuddle command line, but I'm going to let Jinjin talk about our plans around packet capture and once we get here to the end of the demo. So hold that question, and Jen, if you can be thinking about a response on that, that would be awesome.
All right, then another question in regards to the service mesh integration, at which level will the integration be done?
That's another great question. So as you know, there's a lot of different service mesh capabilities out there, or implementers right now. And so what we want to do is provide a data plane API so that when we're thinking about things like service lookup and acceleration of a sidecar proxy, right? We want to make sure that you've got all the right data plane primitives to make that happen. A lot of, we're actually seeing service meshes too, even, with and without sidecar proxies, especially when we're dealing with maybe including non-traditional workloads in that arrangement. And what we want to make sure is that people are writing policy just once, right? Like you don't want to write your policy for your service mesh and then write your policy for your CNI, and then write your policy even for your IaaS layer and all the way down. What we want you to do is be able to specify the intent on how you want your application connected, and then that intent get rendered at all the right layers in the network stack, whether that be the CNI layer, the network mesh layer, down at the actual fabric and IaaS layer. And so those are the types of integrations that we're looking at. You know, in those cases, a lot of that user intent won't come to the CNI directly, although there may be some direct CNI policy that comes into play from like platform operators or network operators. But the user intent in that case is going to come into the service mesh, right? And so we want to just basically render the subset that makes sense for layer 3 and 4 where the CNI is enforcing policy. In terms of IP support, we also, you know, incredibly important to address or to have IP address management right now. You know, we support a kind of a static assignment to each node, and we're going to be moving into a lot more flexible options there as well this year. And also IPv4 and 6 dual stack, right? As Kubernetes now is beginning is journeying into IPv6, we want to be there right beside it, and applications that want to take advantage of those types of version 6 sockets, you know, that they'll have the capability to do that, and service load balancing as well. And then finally, I think one of the most exciting things that we're doing is this enhanced data path capabilities, right? So we have a lot of network card manufacturers that are actually able to take OVS and run it, the flows actually on the card, right? And so we're already working with a couple of those, and you know, basically we'll be able to offload the policy or the filter processing, right, onto those network cards and take it off of the main processor, which is going to, again, you know, increase acceleration of the data plane and allow us to take advantage of some things like, you know, DBDK, VPP, AF, XDP, those types of things that give us that direct connectivity into an application. So, like I said, a huge feature set. There may be things on this roadmap that I don't know about that you're needing, a solution that you're needing that this doesn't address. That's where I want you to reach out to us and let us know. You know, come be a part of the project and bring your idea to the table. This group of engineers that we're working with are very talented, and you know they love when new ideas come in, and we'll definitely also work to get you up to speed with Project Antrea so that you can actually you know, do some of the coding and contribute yourself as well. Let's take a look and see where our sorry about that, my phone appears to be honking at me. Let's go ahead and take a look at where we are on our demo, and then I need to pass it off to Steve after that. So hold on just a second here. There it is. Okay, so now we are up and running. If you look here, you'll see that, you know, we have a workload node IP that's set up, but if we actually were to do kubectl, and I need to grab the kubectl for that workload, right? So let's pop in and take a look at this.
Another question while you're getting started. Does Antrea have any special features or interactions with ingresses or API or an API gateway?
It doesn't provide that out of the box, but we have some really interesting integrations. And if you would like, afterwards I can, you know, chat about, you know, obviously at VMware we've got a lot of interesting stuff happening in the Tanzu project, as well as, you know, our native NSX, and I'm sure there's some other things out there. You know, if you go into a native cloud, they've got their own load balancing solutions as well. So yeah, we work seamlessly with a lot of those types of solutions, but we're not focused on building, you know, the ingress solution.
So follow up.
All right.
Contour 2, didn't VMware buy them too?
A lot of the Heptio was acquired by VMware, and a lot of the developers that were part of the Contour effort came out of Heptio. And so there's a lot of work still being done on Contour. Okay, so I just logged in, and you'll see I've got an error, right? And if I drill down into here, it's saying, well, these aren't active. Well, the problem is, if you remember, I said that I don't want to install a CNI. And if I actually get the kube config. So I'm just going to do copy to clipboard. Let's do a PB paste to kube. Don't try this at home if you've got other kube configs. This will blow it away. But and now if I do kubectl get nodes, you'll see it's not ready. And the reason it's not ready is we don't have a networking component installed. So we need to do that. And so remember I downloaded the Antrea.yaml component before we got started. And so I literally should be able to do a kubectl apply -f Antrea. And once I've done that, I'm going to watch. Actually, we'll get pods. And as this rolls out, the problems that and errors that we saw from cattle system and the other rancher components will now get resolved because we'll actually have a running CNI in place. And so it's as simple as setting it to none, running that Antrea piece. Now, obviously, if we want to get into non-overlay and other situations, those certainly can be done, but it would require a little more configuration on the Antrea side, and I think that's where the real problems start to get solved.
That's awesome, Cody. So we got about 5 minutes. Any follow-up questions before we give the floor to Steve? All right. So Anton had said that regarding packet tracing in Antrea, if we don't have time to get back to before the next presentation, the GitHub issue is VMware Tanzu Antrea issue 631, which has the design documentation.
Excellent. Thank you so much for putting that on the chat. My final thing that I want to, before we go back and look at the Antrea load is, again, I've said this multiple times tonight, and I sincerely mean it. We want your help. We really think it's a cool project, and if you really want to learn and dive into the bowels of networking, I've got some of the smartest networking minds working in this project, and you would really learn a ton about how packets actually move around, not only your network but in a Kubernetes cluster, and gain some really valuable skills. And so, if it's something that you think is up your a skill that you want to add to your skill set and it'd be up your alley, then let's chat and let's find an issue to get you started on. We have a Antrea channel on Kubernetes Slack, so we always have folks that are hanging out in there. We'll be glad to answer your questions, whether you're just trying to use Antrea or you're trying to contribute. And additionally, we have some additional mailing lists, and of course we use the GitHub, for all of our issue management and to contribute. We are hoping in the very near future here to propose going into the CNCF as a sandbox project as well. And again, we're trying to evolve networking kind of to the next step within Kubernetes, and we think that this project is the right vehicle to do that. All right, so let me switch back over. Let's see if we have everything running. We have everything except the ingress controller, and it will come around. It always takes a little bit of time to do its thing, but we should already actually be able to see if we ask for our nodes again. Now our cluster is ready. Antrea did what it was supposed to. It established a VXLAN overlay, and now we can start using it as we would any other CNI. So that's all I've got, Jason, in terms of Antrea tonight. Again, I'm going to provide this deck. I'm sure you're going to post it somewhere, Jason, if you want to take a look and look us up.
See it.
Perfect. So I'm going to spend the next about 35 minutes talking about the journey that we have been on at Mettle towards throwaway clusters. So I want to start with this quote from Kelsey. So Kelsey said, once you found success, your next goal should be helping others to do the same. I kind of want to change that a little bit and say, once we found a pattern that works, the next goal should be helping others to do the same. We're all on this Kubernetes journey together. The platform team and the engineers at Mettle have been on a journey to get to where we are today. And I want to share that journey with you, and hopefully you can take some things away and implement those at your companies. So just a little bit of a background on what Mettle are. Mettle are a digital-only business bank. So no branches in the UK, everything done via your mobile phone or via your iPad. So we have the ability for you to be able to create invoices, for you to be able to chase your clients for payment, for you to be able to capture your receipts, and also for you to be able to export your kind of invoices and provide those to your accountant, all at the click of a button within your mobile application. So Mettle is driven to be self-service for developers. That was one of the main ambitions that the platform team had when it got assembled. We run in public cloud, we run in AWS, and we leverage open source tools by default. So there's no licensed products that run within our platforms at all. Everything is open source. So that allows us and provides us with the flexibility to pick and choose the best tools for the job. We're cloud native architecture, so we run everything on Kubernetes apart from our databases, and then we leverage some Amazon components such as S3. And our main principle is that we will drive everything as code. So everything being like Cody showed, Terraform execution for our platform, all the way up to how we actually deploy our applications and how we reconcile clusters. So like I said before, everything is running in Kubernetes on Amazon, and we have a number of different environments. So each platform engineer has a personal sandbox that they use for testing. So lucky enough for me, I'm going to be able to go and test out Antrea and not cause any of the other platform engineers any problems. We have a platform sandbox, which is essentially our platform playground, if you wish. So that's where we can test out new tooling. That's when we kind of put things in place and make sure that they are hardened, and we learn some rules for them before we roll them out to the development environments. And then we have development and staging. We have a bug bounty program so people can hack us and tell us if we've done anything insecure. And then we have a production environment. And then finally, we have a tools environment, and that's where the developers run things like Concourse for their CI. And we're destined for more, right? Because developers love to, they always want another environment. Steve, you know, we want to do performance testing. Can we have another environment? Well, you've told me that you've made this really easy for us to stand up a new environment. So the answer can never be no, right? And now we put ourselves in a position whereby we need to be able to rubber kind of cookie cutter and rubber stamp these environments out. So the agenda for tonight is a little history lesson on what Mettle's platform used to look like. So a kind of TLDR there is a gentleman started off in the platform team and built something that was able to service a small number of customers and allowed us to be able to demonstrate to the business unit that we worked within the value of Mettle and the proposition. And then from there, a platform team kind of rose from the Phoenix essentially, and we started this journey together to build out a platform that would truly scale to the demand and ambitions that Mettle had. On that journey, we learned a lot of lessons, like I've already alluded to, and I'm going to go through those lessons one by one. Then I'm going to touch a little bit on what's left to do, because the journey is not complete yet, and then I'll hand it over to you guys to ask us some questions. So a look back at what Mettle's existing platform looked like. So this is what was kind of inherited by the gentleman that was there when I arrived. So it's very much ticket driven. So a developer would create an issue in GitHub, and if you were lucky, it would be dealt with. But as we know, with all sysadmins, they're too busy working on something else, and you know, the issue never got picked up. And then you've got a developer asking, "Where's my RDS database?" Steve, I created a ticket in your platform engineering backlog 2 weeks ago. I haven't been able to release my microservice, and now my delivery manager is asking me what's going on. So that's not great. But the real illusion is kind of like this, and the old platform was very much like a piece of Jenga. So you'd make a small change to development like this, and then you do it to staging, and then you'd finally roll it out into production, and then basically this happened. And the reason was because the environments didn't really look like each other. So a prime example was dev and staging inside Amazon were in the same VPC, in the same subnets, all with crazy numbers of load balancers. I don't think I've ever been in a company whereby we managed to max out the number of load balancers that you could have in Amazon. That was quite an impressive achievement. But what that provided was this, right? I had to go up in front of management and they were like, Steve, you're a consultant. We're bringing you in to build this next generation platform. And the thing keeps falling over all the time. Are you really the best person for the job? And then this happened, right? So they had no confidence in us. And our team and the ability that our team had to provide value to the business. So what we needed to do is stop pulling in different directions. So we had developers that wanted to deliver new features, and then we had the platform team that was trying to make this thing resilient. And it didn't really work. It was a tug of war, right? So developers would always blame platform engineers, and platform engineers would always blame the platform because the guy that built it knew it wasn't stable. So what we did is we hit a reset button. And by reset, I mean, we went back to the drawing board, we got in front of a whiteboard and we said, look, we know what we've got right now is not good enough. Let's re-architect this thing from the ground up, and let's fix the problems that are there right now and make sure that developers enjoy the experience of using the platform, and we get out of their way and allow them to be able to innovate. So the journey that we've been on, one of the prime principles for our platform, our rebuild, was to make everything self-service. So I wanted the ability for a developer to be able to do anything in the platform, whether he needs to be able to create an S3 bucket, whether he needs a new secret, whether he needs a new Kafka topic, and ideally whether he needs a new cluster. That's the end goal. If he or she wants a new cluster, they should be able to create that cluster, and we put a set of roadblocks and kind of guardrails in the way to make sure they don't do anything too silly. So we started off with a mission statement like every good enterprise team does, and our mission statement was this. So we wanted to provide an easily extensible, config-driven ephemeral platform with clear ownership and, most importantly, reliable and consistent. So there's a hell of a lot of buzzwords in that sentence. And obviously management love buzzwords, so we'd already got buy-in from management just from this sentence. But actually now what we needed to do was actually deliver on this. So what tools did we use to enable this? Well, we used Terraform for our version controlled infrastructure, and then we used Flux, and we use Flux extensively. So Flux is going to allow us to be able to reconcile resources and state from a number of GitHub repositories, and kind of rise of the Phoenix style deployment of how the cluster kind of comes up. And then we used KubeBuilder, and KubeBuilder is an SDK to allow us to be able to create a number of Kubernetes operators, which I'll come on to in a bit. So let's start with easily extensible and config-driven platform. So as I said before, we run in Amazon, and then on top of Amazon, we run Kubernetes, and then on top of Kubernetes, we need to run the Mettle workloads. So this is kind of a very, very simplistic diagram of what the platform looks like. So from an infrastructure perspective, we have a dedicated repository for all of our Terraform modules. So all of our Terraform modules live and reside within a single repository. And then we have a number of dedicated Terraform routes. And what those routes do is they consume one or more Terraform modules. And the routes that get created are dependent upon the life cycle of the execution. So as an example, the Kubernetes cluster, as Cody alluded to, the rate of change and the upgrade path, and they're always coming up with new releases. That thing has a more iterative cadence than our data routes, such as RDS. If we go and delete the developer's RDS cluster, they're going to come and stand over at my desk. Well, luckily enough now we've got COVID, so they can't really do that. They'll just kind of call me on Zoom. And then so every one of our environments is built using these sets of Terraform routes, and they're executed in a specific order. So here is an example of what our Terraform modules route looks like. It's essentially a bunch of Terraform modules And then within there, we have broken this down into a number of different modules for different things. So everything that we build inside Amazon is built from one or more of these modules, from the organization in Amazon to the account in Amazon to an EC2 instance like Kodi span up for us to be able to run our Kubernetes cluster. And then we have routes here. So this one is a Terraform env K8, and you can see this is the production route by the PRD here. And we instantiate a module, a Kubernetes module based at a given Terraform hash, and then a Git hash, sorry. And then we execute this Terraform code, and up comes the Kubernetes cluster based on that module hash. So a key thing to note here is that when we are creating environments, we use this 3-character prefix everywhere. So you're going to see that through the remainder of the slides. So if it's dev, it's dev, if it's production, it's PRD. And we follow that all the way through from Terraform all the way up to the way that we deploy the code. So there's 2 main modules that I want to focus on right now, and that's the application IAM module and the application S3 module. And the majority of the platform is already there, right? The shell already exists. But from an application perspective, they really just create S3 buckets for their microservices to be able to read and write from. If they want to create more infrastructure, they have the ability to be able to do that, but these are the main 2 that they leverage. And then we have another Terraform module called Data EV. So EV is one of the products that we run within Mettle. That is kind of the main banking proposition, essentially. And you can see here that we are calling out to specific Git hashes for those 2 modules, and then they can construct their own IAM roles for their microservice. So in this example, it's a bills microservice. It needs an S3 bucket, and it needs the ability to be able to read and write and delete from that. So abstracted away behind that application S3 module is all those good things, right? Versioning, encryption, et cetera, et cetera, et cetera. Things that developers don't really want to care about because they just want to get their code into production. So all of the kind of best practices from a Terraform and Amazon perspective are abstracted away from them, and they have this module as the kind of interface that they implement with. Ooh. Let me stop there. Do we have any questions before I go any further? I can't actually see the chat.
So at any time, if you want to look at the chat, you can hit Alt-H and the chat will pop up, but no questions so far.
Okay. So how do we actually make this platform ephemeral? Essentially, everything is driven from GitOps. So by GitOps, I mean, like when you're used to using Kubernetes in the example that Kodi gave, Kodi run a kubectl apply, or you may run a kubectl set image, or you may run a Helm upgrade. We do none of them. All we do is a git push or a git merge. So how does this work? So on the left-hand side, you have a cluster Git repo that can contain a number of manifests. So all the manifests in here will be the Kubernetes manifest that you're used to create the default infrastructure or the default Kubernetes cluster that you want to run. So in there, we'd run our CNI. So we run Calico, we could run Antrea, or we could run Cilium. And then all of the other utilities that we need to be able to create our cluster, whether that be Nginx Ingress Controller, Prometheus, Grafana, Kibana, anything like that sits inside one of our kind of Git repos. And then we have Flux that sits inside the cluster, and that's doing 2 things. It's reconciling the state from our Git repository, but most importantly, it has the ability to be able to look for new images with a specific tag in your container registry and automatically deploy them. And then most importantly, write back to Git telling you that it's done it. So now what we have is we have an audit trail, right? Because Git is our audit trail. Every change that's ever made to any cluster now is going to reside in Git. So as we are a bank, the ability for us to be able to, at any point, the auditor to be able to come in and ask us what change was made yesterday at, between the hours of 9 till 5, we can easily show them all of the commits that happened. and that is our changelog, essentially. So it's a very powerful mechanism. This is just a kind of exploded diagram. So at the bottom left there, you can see that we don't leverage kubectl apply. The developers push container images into the image repository, which is top left, or commit manifests to a number of different repositories. And then Flux inside Kubernetes, which is that dashed box there, takes control and is the thing that's doing the deployment. So we've kind of split out CI and CD. The developers are in control of CI and testing and pushing images. And then we have this agent inside the cluster that is responsible for completing the deployment. At Mettle, we are heavy Helm users. So Flux has got a sister or a brother called the Helm operator. And what that allows you to be able to do is declaratively declare the state of your Helm chart. So where you were used to supplying a values.yaml and doing a Helm install and passing in an additional file for your values, you don't do that anymore. You tell in your Helm release the chart and the version of the chart that you want and the values that you want to specify. And then the Helm operator is the thing that is interacting with Kubernetes and doing your Helm upgrade or your Helm delete or your Helm install. So here is an example of a Helm release. So this is our sealed secrets Helm release. And you can see that here we're calling out to a repository. So Kubernetes charts, so they're the stable charts. We're going to use the chart called sealed secrets within that repository. And we're going to use the chart version 1.3.4. You can also add these annotations. This annotation is essentially saying for any chart, for any image tag that matches that senver, update that image inside the Kubernetes cluster and then write back to Git telling you that it's done it. So this is quite powerful if you think about the potential way that we're now going to deploy new images to dev staging and prod. We're going to use this image tag prefix to be our environment hash, so dev being dev or prod being prd, and we're going to leverage this these Flux annotations for us to be able to automatically deploy new versions of our microservices to different environments. Sealed secrets. So I don't know if any of you are familiar with Bitnami sealed secrets, but we leverage that with inside our clusters. So we have a Git repository called Kubernetes secrets. All of our Kubernetes secrets live within there. They are sealed, so they are sealed with a public key. The only private key that can decrypt it is the private key that's running in the Kubernetes environment for that specific sealed secret. And then Bitnami sealed secrets converts that sealed secret into a secret for the developers to be able to leverage. Multi-tenancy, this diagram is taken from Helm 2. Essentially it was this, right? It's actually a headache because of Tiller, and Tiller needs pretty much God mode to be able to manage all of your Helm releases within your whole entire cluster. With Helm 3, luckily that goes away. And you can actually use the RBAC permissions on the Helm operator to determine what Helm releases that specific instance of the Helm operator has and should be in control of. So thankfully that's actually been relieved and I don't have to take any more time. So we have 2 or 3 main repositories. So all of the platform engineering resources live in a repository that we call Kubernetes resources. We are heavy users of customize, so you'll notice down here that we've got a customize directory. And then if we drill a little bit further, you'll see that we have another repository called K8 releases Mettle, and this is where all of the Helm releases for all of the microservices live for every single environment. So let's take a closer look. Here is an example of a K8 Helm release in dev for what we call account balance. So you'll notice here that we're in a dev directory. So the glob that we're going to use for the image tag is going to be dev-star. So anytime a developer deploys a new, uploads a new image tag with dev-something, Flux is going to see that inside our image repository, which is key.io, deploy that new version, and then write back to Git telling it that it's done that. And you can see that actually here. The last release was 3 days ago, and it deployed this version. So we came up with this concept of we were going to use this 3-character prefix for our environment. And then after that, we were going to use the long commit hash. So from a CI pipeline perspective, now we have this kind of cookie cutter pipeline. So you build a new image, you tag it with dev-commit hash, you upload it to our image repository, you wait for Flux to do what it needs to do. Once it's done that, you run your tests, and you then upload the exact same image with stg-, and that's going to automatically deploy to staging. And then it's just an iterative, repetitive loop for us to be able to deploy dev, staging, DBP, production. Here is an example of us actually writing back to Git. So you can see that essentially the tag has been changed, which means a new version of our microservice has been deployed. And then all we did was copy and pasted this for every single environment that we had. We built out development. We used that dev- and that long commit, and then copied and pasted a lot of Helm releases, changed everywhere where we had dev, dev to stg, made the necessary environment changes to the containers that were running or the pods that were running, and then essentially we have a running version of staging. So we kind of got an understanding now of how we build this, but how does the kind of cluster actually come up from the ground up? So we use Terraform with AWS to create our Kubernetes cluster. Inside our Kubernetes cluster, we leverage Bootkube. So Bootkube was actually started with CoreOS and was used within Tectonic. And what that allows us to be able to do is define what we mean by a vanilla cluster. So we don't just deploy the control plane and Calico as our kind of overlay network there. We actually deploy what we call a bootstrap flux. And that bootstrap flux looks at Kubernetes resources. And inside Kubernetes resources, like we've alluded to before, comes Prometheus and Grafana and Nginx Ingress controller and Istio and everything that we need. But most importantly, it brings up some more fluxes. Here is an example of the definition for Kubernetes resources. So we essentially point at a specific path within the repository, and we also create a sync tag so that every time that Flux has successfully sunk, it also writes back to this tag so that we know that it's constantly kept up to date. So the additional fluxes that it brings up is it brings up a flux for K8's releases Mettle, because we need to deploy the Mettle workloads. It brings up another flux for Kubernetes secrets, and that's going to deploy our sealed secrets for us. And then finally, it brings up another flux for our Kafka topics, and that's going to deploy our Kafka topics. So we have a Kafka topic operator that we wrote using Kube Builder, and that takes the declarative state of our Kafka topics, looks at them, and then makes a decision about what it needs to do, and actually interacts with Kafka and creates our Kafka topics. Reason why we did that is because our developers used to come to one of us to say, Steve, my new microservice requires 2 Kafka topics, and I'm kidding you not, we would go onto the Kafka machine and actually execute the commands to create the Kafka topics. Now we have this all in desired state and declarative state. So we just have a repository called Kafka topics, funnily enough, with a directory structure very similar to what you saw for K8's releases Mettle. And in there, you define the specification of your Kafka topic. That gets merged into master. And then about 15 to 20 seconds later, you have your Kafka topic in Kafka ready for your microservice to be able to use. So that gives us the ephemeral platform, because now we have this ability to tear down the cluster, spin up a new cluster, and we know that these fluxes are just going to reconcile the state of the repositories and bring us back to where we were before. But we wanted to also make this reliable and consistent. So how do we make sure this is reliable? Well, we leverage a tool called Chaos Cube. And if you don't know what this is, I'll leave this on the screen for a couple of seconds because it is invaluable. It's essentially Chaos Monkey, but for Kubernetes. And it will randomly kill a pod in Kube every 10 minutes. And you can configure that to run in, not run in specific namespaces or run in specific namespaces. We run this in every environment, including production. And it taught us a lot of lessons. We thought that we had monitoring nails, but actually we didn't. And it's constantly discovering new problems, and it's allowing us to be able to really hone in on our observability without waiting for an incident to happen, because it's kind of causing an incident every 10 minutes. I think there's a question here.
Yes, in the chat, chaos cube equals my operations group normally maintaining a working system. It's kind of a joke, but makes sense.
Yeah, it's great, right? It's really become extremely useful. A prime example is we didn't actually tell the developers that we were running this in production. We just let it happen because they told us that their microservices would never go down and they were perfect, and it turns out that they were lying. But they actually learned some useful lessons from that in our downstream environments before we rolled this thing out to production. Another thing that we do is we repave our clusters, so we don't want long-lived nodes. In the past, in the old kind of platform world, we had nodes that were upward of 500+ days that people had SSH'd onto, created directories, dropped keys in there, done everything. So we like to rotate our nodes on a regular cadence. So in terms of those three kind of big ticket items, we have successfully met the mission statement as far as the business are concerned. We now have a scalable platform. We now have the ability for our developers to deploy any of their microservices that they want and totally get out of their way, right? So now the developers and the engineers can innovate and we can focus on, stability of the platform, better observability in key areas, and also some new features that we'd like to implement. So what has GitOps given us, or this kind of paradigm given us? And I think the real benefit for us is it's given us stricter CI on pull requests. And now we can use the pull request to make sure and provide a mechanism to stop dodgy things getting deployed to Kubernetes, right? You've got to get past a number of CI checks before you even get anywhere near reconciling or deploying your application into a Kubernetes cluster. So some kind of tools that I want to call out here if you're not using already. Kubeval is great. We use Kubeval to strictly lint our YAMLs against the upstream Kubernetes schema. So every single YAML that gets deployed, whether that be a Helm chart or whether that be a YAML within one of our repositories, is strictly Kubevaled against the upstream schema. And that means that when we're doing an upgrade, so we upgraded from 1.14 to 1.17, spoiler, don't do that, because they deprecated a number of APIs in 1.16, and luckily enough, this stopped it, and so did something else, which I'm going to come on to in a second. But this just means that we're constantly keeping up to date, and we're not allowing developers or platform engineers to deploy YAMLs that aren't strictly to the specification. Another thing that we leverage is deprecates. I know this is one of Jason's favorite tools. He even talks about it in his Rancher Labs. And what this does is we wrote a set of rego policies. So if anyone isn't familiar with rego policies, it's what Open Policy Agent uses to kind of declaratively check resources for compliance. So we actually, I wrote a number of rego policies for us to check deprecations of the API versions. So an example is here. So this is the 1.16 rego policy. So this is checking any resource for the APIs apps v1 beta 1 and apps v1 beta 2, and then denying that and telling you that you need to move to apps v1. This was extremely useful for us because it caught a lot of problems when we were going to 1.17. It's completely open source. Use it. I'm actually collaborating with someone from Red Hat about turning this into a GitHub action as well for you to kind of constantly be checking this. I'm going to keep this up to date as well. Oh, I don't know why I have the same thing in there twice. The other one that I'd like to call out, and this is the wrong slide, is HRVal. So HRVal is a tool created by Stefan Prodan from Weaveworks. And what that does is it links your Helm release. So how that works is it takes the Helm chart at the version that you specified, template, pulls that down locally, passes in your values that you've declared in your Helm release, does a Helm template, and then runs kubeval against it. And we run this constantly as well now to make sure that your Helm release specification is actually accurate and will get successfully deployed to Kubernetes before you actually merge to master. So I just wanted to leave you with some statistics here. So last month with this kind of process, 447 deploys to dev and 218 deploys to production, to which 216 of those were successful, 2 of them weren't. And then we went back and added more aggressive rego policies to stop that from happening. And that was due to Cert Manager deprecating some options on their ingress resources. So just want to leave you quickly with some quotes from some engineers. So Genie was a brand new project, brand new team that had 2 developers that had worked on the EV project, and they got a proof of concept all the way to production in a number of weeks with 0 help from the platform team. And that's where we wanted to get, right? We wanted to get out of the way of developers and allow them to be able to innovate and do the things that they do best. I'm going to skip that one. And true GitOps means that the developers can move fast, and no matter what they need, they can always create a PR for it. It may not be the perfect PR, but we'll catch it as part of the release, the review cycle. What's left to do? Essentially, progressive delivery or canary releases. So right now in Kubernetes, you obviously can do a rolling upgrade, and that either turns you into great success or a catastrophic incident. And when you're running a bank, that's not really the greatest look. So we want to be able to do this fine-grained delivery process whereby we roll new features out to customers, validate that they're working, and then roll them out to a wider audience, and then gradually roll the whole new version out to 100% of our users. So in summary, I think having a consistent naming convention is key for all of your environments, and leverage that throughout your whole entire kind of ecosystem, like an environment taxonomy or a labeling taxonomy. Always think pull-based rather than push-based. It actually makes you think about a lot of things. One of them, and I actually have a presentation on this, is handling your monitoring stack, right? So Prometheus allows us to be able to define alerts inside code. So we actually have a pull-based mechanism for how we pull the configuration for Prometheus and Alert Manager in from another repository. And then finally, failure will happen. So be ready for it. Use things like Chaos Cube. Use things like the deprecation checker to try and make sure that you're testing these things ahead of time. I'll leave this on the screen for a little while. These are a number of useful links. So yeah, we've got Customize there, we've got Flux, we've got Vietnamese sealed secrets, and then I've left a link to my blog posts where I go into this stuff in a lot more detail than I can do in about a 35-minute presentation. And I just kind of want to leave you with this slide. So Nginx Ingress Controller overnight for us here in London released a new release of the Nginx Ingress Controller with a CVE fix, and we had that running in all of our environments within 30 minutes of us starting work. And I think that's the real true power of GitOps, right? We validate in our sandbox environments. We use the strict CI to make sure that we're not doing anything silly. Once we have that, we make those changes into all of those environments. They automatically get rolled out, and then they commit the fact that they've been successful back to Git, so that we know we're in a good position. That's everything. I'll open the floor up for questions.